This is the Cantilever beam recommendations for Team 7. Group members are Robert Fox, Ryan King, and Austin Watson.
To determine each exponent, we held all parameters constant except the one in question and recorded 4 separate data sets. For each data set, linear plots of force versus deflection were created. The slopes from these plots were used as stiffness, and a power trend line was fitted to stiffness versus the altered parameter. On this slide, you can see examples of our plots for force versus deflection and stiffness versus length. Our geometric constant C was calculated for each data set using our data and exponents. An average geometric constant of 0.24 was calculated.
The first table compares the predicted deflection from our program versus the actual deflection obtained from testing in the lab when a constant mass of 1,000 grams is applied to a beam with certain parameters. The light blue column shows percent error between the predicted and actual values. The second table shows when achieving a deflection of 1 inch with a given beam dimensions, the predicted mass from the program is compared to the actual acquired mass from testing. Once again, the light blue column shows the percent error of the tests. Notice the highest percent error is 20%.
This slide shows the final recommendations we made for the Engineers Without Borders team. To provide an accurate recommendation, we considered various beams with different specifications, the number of beams we would utilize, beams that met necessary specifications, and the price of the beams. We utilized our available beams and decided the best choice would be to use 3 beams. Beam 1 would hold the velocity flow meter. It has dimensions in inches of 18 by a quarter by a quarter. It is made of stainless steel and costs $10. Beam 2 will hold the turbidity meter. Its dimensions in inches is 18 by 1/2 by a quarter. It is made out of aluminum and costs $10. Beam 3 would hold 3 objects: the portable sampler, the nutrient meter, and the pH electrode. It has dimensions in inches of 18 by a quarter by a quarter. Its material is stainless steel and it costs $20. This gives us a total cost of $40.
The main driving force influencing our decision was the cost of each beam. Aside from cost, we found 2 of the beams available: the 30-inch long aluminum beam and the 24 by 1/2 by 1/8 inch stainless steel beam were not capable of supporting even a 1/2 pound of force by our predictions. These 2 beams were eliminated because they were unable to support the smallest instrument, which produced a 1/2 pound's force of drag.
The first table on this slide shows all the beams that were available for us to use. We numbered these beams 1 through 6 for clarification. The second table lists the beams that we chose to use, the instruments that are attached, the drag force from each instrument that will be applied due to the flow of the water, the total drag force that will be applied to the beam, and how much our MATLAB program predicted the applied force would cause the beams to deflect. Once again, the total cost is shown at the bottom.